Let's solve some exponential equations. First thing to do is isolate your exponent as much as possible, and then to bring down a power you take a logarithm. So let's solve this one. Let's isolate the 3 to the x. To bring down this x, let's take a log base 3 of the 3 to the x. If we do it to one side, we better do it to the other. Log base 3 of 3 to the x is just x. So we get x equals log base 3 of 29. Now let's do this again and see what happens if we used, instead of a log 3, a log with a different base. Okay, let's natural log both sides. Okay, our x will come down in front. That's this rule here. So to solve for x, we divide both sides by the natural log of 3. These are actually the same answer because we could use the change of base formula on log base 3 of 29 using base e for the new base, and you would get exactly this. And let's get a decimal representation of this answer. We get 3.065. Let's solve this one. We can't really isolate the exponent because there's two of them. So let's go ahead and take a logarithm of both sides. Let's go ahead and use natural log. On the left side, we can't bring that 5.1x out front because it's just the exponent on the 3.2. That 1.7 is messing us up. So let's look at this rule. Log of AB is log A plus log B. We can split that up that way. We can bring down this exponent. Once we've split those up, we can bring that 5.1x down also. Now we need to solve for x. It helps to remember that natural log of 6.2 is just a number. Natural log of 3.2 is just a number. So we're going to solve it like we normally do linear equations. Get all the x's on one side, all your other constants on the other side. Now we want to pull out an x. We're going to factor an x out of the left side. This is all just a number, so we can divide by it. There's the answer. Let's get a decimal representation on it. Be sure you tell the calculator about the parentheses around the entire denominator. We get negative 0.070.